Good afternoon, everyone. My name is Chen. I'm from Auckland, New Zealand, and I will present our work on UAV thermography for building energy audit, mainly focused on comparing image acquisition strategies. I will introduce it from three parts. Start from the background. The climate change presents urgent and escalating challenges like the global mean temperature and also global mean sea level continue increasing and reached the highest value in 2023. And while the building sector accounts to around 30% of the global energy consumption and 26% of the greenhouse gas emission, therefore, it is important to improve the energy performance of existing buildings to reach the climate goals such as the net zero 2030. As the insulation between the internal space and the external environment, the building facade plays an important role in the building energy consumption. And one common method for assessing the facade energy performance is using infrared thermography, like particularly combined with the high mobility of the drones, we can like easily collect images of the building facades even for the high-rise buildings. And in one of our previous work, we developed a method to register all the UAV collected images onto the BIM model, and then to gain a holistic view of the thermal condition to support the visualization and also the decision-making process. The problem is that most current research mainly focused on processing the collected thermal images, but not much attention has been paid to how to collect these images to support the analysis or decision making. Yeah. This research aims to narrow the gap by investigating the UAV thermal image acquisition strategy, mainly focused on three key factors. The first one is the temperature differences between the interior and exterior environment. The second one is the grounding sampling distance of the collected thermal image. And the last one is UAV optical angle. The thing is that it is quite difficult to get the ground truth of the thermal anomaly of a real world building. So to support the investigation, we developed a laboratory scale building with artificial anomalies. The building is designed reference to a timber framed building, which is the most common building in New Zealand. And we consider two types of thermal anomaly. The first one is the insulation failure, including the missing insulation and the thin insulation. And the second one is the surface deterioration with different widths, like dimensions from 5 millimeter to 100 millimeter. And then we collected thermal images of both the anomalies under different configuration of these factors for the comparison analysis. And then here's the results. The first one is regarding the temperature difference between the interior and exterior environment. And as we can see that as the temperature difference is increasing, the image contrast and also the visibility of the thermal anomaly increases. Like when the temperature difference reaches like 6 degrees, all these anomalies can be like identified from the thermal images. And we also conducted a quantitative analysis of these thermal anomalies by using k-means clustering to segment the anomaly from the image and then measure their area. So that figure is like the calculated relative error of the measurement of the missing installation. Like we can see that the relative error decreases significantly at the beginning, but then it kind of tends into be a stable, like within 10%. The 10% maybe seems like a little bit large, but we think it is still acceptable because of the like characteristics of the thermal images, like the blurred edges. Yeah. And we also conducted the quantitative analysis based on the surface deterioration to see the like impact of the different deterioration dimension. Like we can see that as the like dimension of the surface deterioration decreases, the relative error increases significantly. The thing is that you can see that particularly for the surface deterioration with a width of 5 millimeter, it is even kind of almost impossible to accurately measure the dimension of it. The relative error is like over 100%. It should be noted that all this image is collected with a GSD of around 3 millimeter. Like if we like reduce the image GSD, we might get a better result. So this is the result for the GSD of the collected thermal images. Like also as the GSD increases, the contrast of the region of interest and also the visibility of the thermal anomaly decreases. And also we did a quantitative analysis on the missing installation, like to quantify the measurement error corresponding to the GSD, and to achieve a relative error less than like 10%, image GSD like within 5 millimeter is recommended. And we also did the quantitative analysis on the surface derivation for like different dimension of the anomaly. And we can see that for the small deterioration, it is possible to increase the measurement accuracy by collecting images with a smaller GSD, which is like we collect more close range images. It is possible. Yeah. And then we analyze the influence of the UAV oblique angle. Like as the UAV oblique angle increases, like it is likely to include some unwanted background in addition to the region of interest. So this will like reduce the contrast of the region of interest. So it's kind of recommended to collect thermal images with a oblique angle within 30 degrees and also with a preference for a perpendicular view. And it is found that compared to the GSD, the UAV oblique angle has a minor impact on the defect quantification. Yeah. And in addition to the laboratory investigation, we also did a field validation on a real world building. We mainly did 3 cases. The first one is like investigating the impact of the GSD. And the second one is on the UAV oblique angle. And the third one is we have like some conclusion on the recommendation on the image acquisition. So we followed that recommendation and did a comprehensive inspection of the targeted facade. The result is pretty much aligned with the laboratory investigation, like GSD like within 5 millimeter and UV oblique angle within 30 degree is recommended for the inspection. And for the that 2 images is for the comprehensive inspection of this whole facade. The interesting thing is that, we kind of like use the method we developed in our previous research to register all the UV images with the beam and then map them into a holistic view. The thing is that for the window part, because it's kind of the glass, so it always reflects different background. So it is kind of very disturbing about this whole image for the analysis. So also since it is already aligned with the beam, so we use the beam information to segmented all the windows and then improve the image contrast and then convert it into the color space. And this is the result. And I can't say it's like perfect, but I think it's still good enough to identify some potential thermal anomalies from that image. Yeah, basically that's all for my presentation. And this is still an ongoing research. So I would really appreciate your opinion on potential improvement and also happy to answer any questions. Yeah. Thank you.